Okay, so then there's a particular kind of rate, time, and distance problem that you have to deal with. And I'm aware that there are actually many different kinds of rate, times, and distance problem, but so far it seems like the only rate, time, and distance problems that you are facing thus far are the ones where you have a common starting point and you have one object going in one direction and then you have another object going in another direction. And as I taught you before, it's good to actually draw that diagram because that diagram is helpful because basically you're capturing a moment in time where at a certain point in time these objects are a certain distance apart. Okay, and that visual can be really helpful. Okay, when you're doing the problem. So let's take a look at a problem. And again, this one's from the book too. Let's see, at 10:30 a.m. Okay, so unfortunately these problems are so complicated that I think I really do have to like write them out. So at 10:30 a.m., hopefully my handwriting's okay. Two planes leave Houston, one flying east at 560 kilometers per hour. Alright, so you know what? I'm just going to go ahead and like represent that immediately. So I have the starting point, I have a plane flying east, and that's going at 560 kilometers per hour. Okay, and it's not 560 kilometers, it's 560 kilometers per hour. So I'm writing the speed right there. Okay, that's the rate that this plane is traveling. And the other one's traveling at 640 kilometers per hour. So basically, I'm going to draw a slightly longer arrow just to demonstrate that this plane's going a little bit faster, so it's going to be traveling more distance, literally more distance in the same amount of time. And that plane is again going at 64 kilometers per hour. And then they say, at what time will they be 2,100 kilometers apart? So then you could draw this bracket and be like, okay, at a certain point in time, they are a distance of 2,100 kilometers apart. Okay? And ultimately, what's the problem asking? They want to know at what time does this situation occur? So what we could do is we could find out how much time elapsed since they started and then separated, how much time they both of these planes have been flying, and to keep in mind that these planes have been flying for the same amount of time. And whatever that amount of time is, we're going to add it to 10:30, and then we'll know what clock time the planes are then 2,100 kilometers apart. Okay, and I'm going to just label that kilometers. Now this is not kilometers per hour. This is actual distance, whereas this stuff is speed. And as I told you before, as I showed you before, it's really a good idea to use that chart, and it always begins by recognizing that rate times time equals distance. You could always remind yourself of that, and then you could draw a table where we have a column representing rate, a column representing time, and a column representing distance. And usually with these rate, time, and distance problems, it often features two objects. In this case, we have a plane flying east and a plane flying west. So we're going to draw rows that help us recognize that. Okay, now, just so you know, I like to write, like there is another kind of secret space down here that represents the total distance. This is the distance traveled by the plane flying east. This is the distance traveled by the plane flying west. And this is the total distance that you get after adding these two distances up. Alright, so we did this not too long ago. We did this like a couple hours ago. So this should be pretty fresh in your memory. So, okay. Then it's really just a matter of like filling in whatever you can fill in. Okay, just going, even if you don't know how to do the problem, just take the information from the word problem and you just plug it right into the table. So the plane flying east, we know that that plane is traveling at 560 kilometers per hour. Just going to leave it as 560. And this one's doing 640. Okay. Now, you correctly earlier in our session today recognized that the time elapsed for this plane and this plane is the same time. So in other words, they've both been traveling for the same amount of time. Now, we don't know how long they've been traveling. Actually, that's one of the things we're trying to find out. But since it's an unknown, we can represent it with a variable. Let's actually represent it with a t. T for time. Okay. T for obvious reasons. I also don't want to use an X because I don't want to confuse it with this multiplication symbol up here. Okay, so we have T for time, and we're safe putting T here and a T here because we know that this plane traveled for the same amount of time as that, namely T hours. Okay. So then it's like, all right, well, what do I do from here? Like, how much distance did this plane travel? How much distance did this plane travel? Well, that's where the table can really come into handy because you recognize that rate times time equals distance. So you might not know the exact distance, but you do know that whatever it is, it's 560 times t. So it's going to be 560t. We know that for a fact. And then we can ask ourselves, what about this? Well, it's the exact same thing, 640t. And we also know that when you add this plus this, we're going to get the total distance. Now the problem gives us the total distance. The total distance is 2,100 kilometers to be specific. I feel like it's okay to get rid of this. Alright, so there you have it. Once again, this thing plus this thing equals the total. So that's just begging to be written as an equation. So we have 560t. Plus 640t equals 2100. Okay, well 560 plus 640 is going to be 1200t. Hopefully my math is good. My mental math is not always the best. And that equals 2100. Okay, so let me just double check. 0 plus 0 is 0. 6 plus 4 is 10. Carry the 1. 5 plus 6 is 11. Plus that 1 gives us a 12. So it looks like we're on the right track. Now, I can already see this problem is going to be a little bit complicated, but as long as you're with me so far, we're good. Okay, so we're perfectly poised to solve for that t, and I'm going to just use my calculator. 2100 divided by 1200 is 1.75. So in other words, the time elapsed is 1.75. But, of course, it can be confusing. It's like, oh my goodness, 1.75 hours, what does that mean? Does that mean 1 hour and 75 minutes? Well, actually, it doesn't. Here's where you have to kind of do a separate little project if you end up with a decimal like that. Now, when you take your test, you might not end up with a decimal like that. It might be t equals 2, and that would be awesome because it's like t equals 2 hours. Done. You know what I mean? And then you just take 2 hours and add it to that 10:30, and it'll give you 12:30, and then you'd be finished. But this problem is a little bit more complicated because it's got a 1.75. So I'll just tell you right now, the 1, if there's a whole number in front of the decimal, that definitely means that that's 1 hour. Okay, so we'll keep it in black. 1 hour for sure. So this 1 perfectly corresponds with 1 hour. But then it's like, what about this 0.75 thing? What does that correspond with? Well, again, you're going to have to recognize that 0.75 is a decimal. we have a whole number, and then we have like this decimal being added to that whole number. It's literally 1 hour plus 0.75. And I'm just going to write that. We have 1 hour plus 0.75 hours. And when you add those two up, what do you get? You get 1.75 hours. Now we already know that this one corresponds with 1 hour, but the question is, what does this 0.75 correspond with? Well, basically the way to handle that, the best way to handle that, in my opinion, is to set up a proportion. Okay? Now what that proportion would be is, first of all, remembering that 0.75, when you convert that to a fraction, is really 75 over 100. Okay? Now what we're going to do is we're going to set that fraction equal to x minutes over 60 minutes. Because whatever the amount of minutes gone by, it's a fraction of a total hour. Okay, so this is a part of a whole. It's a fraction of a total hour. So it could be 30 minutes over a total of 60 minutes. It could be 35 minutes over a total of 60 minutes. But that's what we're going to find out, because the bottom line is this 1 represents a single hour, and this 0.75 represents something less than an hour. And usually we describe that in minutes. Okay, so we have 75 over 100 equals x over 60. And that's how you find out how many minutes this 0.75 corresponds with. Now, I want you to be very careful here. This is a proportion. This is not multiplying this times this. There is clearly this equal sign in between them. So that means that when you have two fractions with an equal sign in between them, you don't do a cross cancellation. You're doing what's called cross multiplication. Okay? Where you multiply 75 times 60, and then you set that equal to 100 times x. However, I'm going to tell you just from experience that before you do that cross multiplication, it's still always a good idea to go ahead and reduce fractions whenever possible. We have a 75 over 100 here. This is a fraction that can be reduced to a much simpler number. Okay, and I'm going to cut to the chase. This reduces to 3 over 4. Now, how do I know that? I know that because 75 is divisible by 25 and 100 is divisible by 25. 75 divided by 25 is 3. 100 divided by 25 is 4. So instead of working with a 75 over 100 equals x over 60, I would much rather deal with 3/4 equals x over 60. Because that's going to make the cross multiplication so much easier. Okay, we're going to bring it over here. So when we do this cross multiplication, again, it's going to be 3 times 60, which is 180. And that equals this 4 times x, which is just 4x. Cross multiplying in the way that we just did is a way of, in a sense, flattening everything out with an equal sign in between them. It's almost like smushing this fraction down so it's on a single line, and we no longer have to deal with annoying denominators, basically. Alright, so, and from that point forward, you pretty much know what to do from there. You would solve for x, and that would end up being x equals 45. Okay, namely by dividing both this side and this side by that 4. Okay, so we've effectively solved for x. So what this x means specifically is that this 0.75 corresponds with 45 minutes. Okay, so what I'll do is I'll write 45 minutes right here. And I'm just going to make it very clear that this 0.75 corresponds with that. So 1 hour and 45 minutes has elapsed since these planes started their trip. And the problem asks, well, what time do they make it to 2,100 kilometers apart? So we'd have to add this 1 hour and 45 minutes to this 10:30. Whenever I do that, like you probably do, I like to just add the hour first. So that's easy enough. 10:30 plus another hour is 11:30. But then it's like 11:30 plus the additional 45 minutes. Well, that would be 12, 15. And at that point, it's no longer AM, it's actually PM. So I'm not sure if your teacher's going to be looking out for that, but that is important to recognize. Okay, so that's how to do that problem.